Hi everyone. Today we're going to go through some questions in which we calculate the empirical formula of a compound once given the percentage composition data. Let's get started. Now, our question tells us that the compound contains 50.05% sulfur, 49.95% oxygen, and it asks for the empirical formula of the compound. The first thing you're going to want to do is start off with 100 grams. So, for sulfur, we're told that the compound contains 50.05% sulfur. So 50.05% of 100 is 50.05 grams. For oxygen, we're told that it's 49.95% oxygen. So 49.95% of 100 grams is 49.95 grams. The next thing you're going to want to do is calculate the number of moles. So we know that number of moles equals mass over molar mass. So for sulfur, we have our mass as 50.05. Our molar mass is 32.07, and that's from the periodic table. Oxygen, our mass is 49.95 grams, and our molar mass is 16. So doing the calculations, the sulfur is going to give us a value of 1.56 when we divide, 1.56 mole. For oxygen, we're going to get 3.12 mole. Oops. 3.12 mole. So what you're going to want to do is determine which one is the lowest and divide both numbers by that. So clearly 1.56 is lower than 3.12, so we're going to divide both numbers by it. Divide by 1.56 mole. So 1.56 divided by 1.56 is of course 1, and 3.12 divided by 1.56 is going to be 2. And based on this, we are able to determine our empirical formula. So we know that there's one sulfur atom, so we're going to leave it like that, and 2 oxygen atoms. So right here is our empirical formula. This question also asks us for the molecular formula. It tells us that the molecular weight for the compound is 64.07 grams per mole. So because our empirical formula is the simplest form that the compound will take, the molecular formula may or may not be the same. So we have to do one extra calculation to determine what the molecular formula is. So if we go down here, we know that the molecular weight is 64.07. First thing you're going to want to do is calculate the molar mass for the empirical formula. So just using our values from the periodic table, we get 32.07 plus 2 times 16, because we have 2 oxygen atoms, and that's going to give us 64.07. We're told that the molecular formula has a molecular weight of 64.07, but we still don't know what it is at this stage. What we're going to want to do is that, because we know it's composed of sulfur and oxygen, but we don't know how many atoms of each. And we're told that this is 64.07 grams per mole. So just looking at both the answers that we got 64.07 for our empirical formula and 64.07 for the molecular formula. Now both of these have the same molecular weight, and based on that we can infer that the empirical formula and the molecular formula are the same. So our molecular formula is in fact going to be sulfur dioxide. 1 sulfur atom and 2 oxygen atoms. Let's move on to the second question. Question 2 tells us that we have 52.1% carbon 13.2% hydrogen, and 34.7% oxygen. It asks us, similar to the last question, about the empirical formula. So, as we said before, we're going to start with 100 grams. For carbon, 52.1% of 100 grams is 52.1 grams. For hydrogen, it's 13.2 grams. And for oxygen, it's 34.7 grams. Feel free to stop the video now and try and work it out on your own. So, the next step is to calculate the number of moles. And as we know, that's mass over molar mass. So for carbon, our mass is 52.1. The molar mass is 12.01. For hydrogen, our mass is 13.2, and we'll take the molar mass as 1. And for oxygen, we have our mass as 34.7, and that's going to be a molar mass of 16. So, feel free to use your calculator now if you're going through these questions. So that's going to give us 4.34 mole. For hydrogen, we're going to get 3.2 mole. And for oxygen, we are going to get 2.17 mole. So as we did in the last question, you want to look for the smallest number, and that of course is 2.17. So we're going to divide all of them by the smallest, which is 2.17. That's a 2 right there. Mole and mole. So this, of course, 2.17 divided by 2.17 is going to give us 1. 13.2 over 2.17 will give us 6. And for carbon, we're going to get 2. Now we can determine our empirical formula. Just write it down here. That is going to be C2H6 and O1, only one oxygen atom. That's our empirical formula. Now, the same way as it was in the last question, we're told that the molar mass of the compound is 138.2, and it asks us to find the molecular formula. So, like we did earlier, we want to know if the molecular formula is going to be similar to the empirical formula or if it's going to be different. So the first step is to find the molar mass. So easy, all we have to do 2 by 12.01 plus 6 times 1 plus 16. And that's 16 right there. And that gives us 46.02. Now we are told, though we don't know the molecular formula yet, so we're going to put some question marks here. And we're told that the molecular weight is 138.2 grams per mole. Okay, so all you really have to do is divide 138.2 divided by 46.02. This will help us determine how many atoms are in the molecular formula. So once we divide these, we're going to get 3. Now, what you need to do is multiply 3 to the empirical formula. So let me switch my color right here. So we're gonna multiply this by 3. So I'll write it down here. That means we're going to have 6 carbon atoms, 18 hydrogen atoms, and 3 oxygen atoms. That's going to be our molecular formula. And this right here is our empirical formula. Now, on to question 3. Question 3 is a bit different than the previous 2 questions we did. This might be a question that a teacher tries to trick you with, and you'll see why. So, for this one, we're told that 57.54% carbon, 3.45% hydrogen, and 39.01% fluorine compose this compound. So we're going to start off like we always do with the 100 grams once we're given the percentage. So for carbon, we have 57.54 grams. For hydrogen, we have 3.45 grams. And for fluorine, we have 39.01 grams. So of course, we want to calculate the number of moles. So that's going to be 12.01. That's 12. It's going to be 1, and that's going to be 19. So for carbon, we are going to get 4.79. For hydrogen, we're going to get 3.45. And for fluorine, we are going to get 2.05. And of course, all of these are mole. As we did before, we're also going to divide by the lowest, and that, of course, is 2.05 mole. 2.05 mole and 2.05 mole. There we go. Okay, so that's going to equal 1. 3.45 divided by 2.05 is going to give us 1.68. And 4.79 divided by 2.05 will give us 2.3. So this is a problem for us because once we were getting to the stage in other questions, we were getting whole numbers. And 2.3 is too high, is like too high from 2, and it's not nearly big enough to round it up to 3. 1.68 is not small enough to be rounded down to 1, but it's not large enough to be rounded up for 2 for our purposes right here. So what we need to do is multiply these 3 sets of numbers by a number that will make all 3 of them into whole numbers, and it has to be the same number. And so let me switch the color here and explain to you exactly what I mean. So if we multiply 2.3 by 2, that still wouldn't give us a whole number. That would give us 4.6, which is still not what we need. If we multiplied 1.68 by 2, that would give us 3.36, which is also not what we need. That's still not a whole number. But let's try multiplying by 2.3 by 3. Let's see what happens there. And 1.68 by 3. If we do that, 2.3 times 3 is going to give us something close to 7, which is a whole number. And 1.68 times 3 is going to give us 5, or at least close enough for us to round it to. So that means we also need to multiply our 1 from the fluorine by 3, because we have to multiply all of the numbers by it, 3. And so because of that, I'll write my empirical formula in a different color right here. Because of that, we are going to get C7H5F3. So like I said, this question is a bit different, but it's not complicated as long as you're able to pay attention to these numbers and recognize when they're not whole numbers. You could try multiplying by 2, 3, 4. It really depends on the question and what works best, but you want to pick the lowest one that's able to make all 3 numbers a whole number. So I really hope you guys enjoyed this video. If you have any questions, please feel free to leave them below in the comments. If you have suggestions for new videos, please be sure to let me know. Thanks for watching.